Hello, grade 11s. We are starting today a new chapter, chapter 1, and this one's all about patterns. So let's start by taking a look at this very famous pattern of the golden spiral. The golden spiral, you should have just watched a YouTube video about it, but basically you start with the number 1, and then the next side you add one more, and the next side we're adding on a 2 because the 1 plus 1 is 2. The next time we're adding on a 3 because the 2 plus 1 from here is 3. The next time we're adding on a 5 because the 2 plus 3 is a 5, and so on. So it makes this perfect spiral shape. Now there's lots of spiral shapes that can be seen in art or other engineering, other forms of science as well. So here's just a few examples. Pause the video here so that you can take a look at these. Now we're going to get into your notes. So you should have this in your booklet. Please start by filling out these notes. So a sequence is an ordered list of objects. It contains elements that follow a pattern to determine the next element in the sequence. So there's an example here of one at the side. It just shows that if you start with 2, the next one goes to 5, 8, 11, and 14, so on. So in this case, we're starting at 2 and then we're adding 3 each time. So it follows a pattern. So you should be able to predict how many would be in the next row. The next row should be 17, because if you add 3 more to 14, you're at 17, and so on. We call the first term T1. So in this case, T1 would be 2, because we start at 2. The number of terms in the sequence is n. So in this example, n is 5, because there are 5 terms in this sequence. The general term is Tn. That's kind of like our formula, and our formula depends on the value of n. So this is where it gets a little tricky. If you think of this pattern as the first term, the second term, the third term, the fourth term, and the fifth term, okay, the fifth term we would call T5. So the fifth term is T5, and the value of the fifth term is 14. So we would say that T5 equals 14. So if you continue on with that pattern, we would then say that Tn, if we don't know which spot we're looking at, Tn has the value n, because again, we're unsure which spot we're looking at, so we're also unsure of the value of that spot. We know that T1 is our first term, and T1 in this case is 2. Now there's one more thing that's important. When we're talking about arithmetic sequences, we're talking about sequences that add or subtract the same amount every time. So this amount that we add or subtract by every time is called D, the common difference. So for this example, D is a positive 3 because we're adding 3 every time in the sequence. A few more terms here. We have a finite sequence. Finite means it has a set number of terms, like a finite number of terms. Here's a couple examples. An infinite sequence goes on forever, so every term is followed by another term. So if you see the ... here at the end of a sequence, that means it just keeps on going and it has no end. So it goes on forever. Pause the video here if you need a minute to finish writing that down. A few more terms. We have, again, an arithmetic sequence is an ordered list of terms which are separated by the same amount. So again, if it's arithmetic, that means we added or subtracted the same amount each time. This amount is called the common difference. Again, we represent that as D. You can always find the common difference by taking a term and subtracting it from the previous term. So in this example right here, we have 10, 16, 22, 28. So what that means is if I take 16 and subtract the one before it, I'll find that the common difference is 6. So you can do that with any arithmetic sequence. The general term is the formula for the sequence. So again, we can always make a general term here. So let's dive a little more into this sequence and see how it works. So for the sequence 10, 16, 22, and 28, T1 is 10, because remember that's the first term. T2 is 16, so again that means the value of the second term is 16. T3 is 22, T4 is 28, and it would continue infinitely. So now let's think about this using T1 and D. So if I'm using T1 and D, for the first term we just have T1. For the second term, we have T1, but we're going to add on 6 because 6 is the common difference, and that's how we get 16. For the third term, we add a 6, but then, because that took us to term 2, but then we have to add another 6 to get to term 3. For T4, again, we start with 10, but we're going to have to add on 3 6s. Okay, so just so we're clear, we're adding on 3. So notice that we are adding on 1 less 6 than the number of term you're on. So if you're on term 4, you're adding on 3 6s. So you can predict that if you're on term 5, you would add on 4 6s onto that first 10. So another way we can think of this is using a formula. So the general sequence, again, is T1, and then for term 2 would be T1 plus D. Sorry, it's a little messy. Next we'd go T1 plus 2Ds, and then T1 plus 3Ds, and so on. Again, pause the video here if you need more time. So this then leaves us with the general term of an arithmetic sequence. Again, that means the equation is Tn equals T1 plus n minus 1 times D. And there's a little more information here for you to look at as well. But this is the formula that's on your formula sheet. This is the formula for an arithmetic sequence. Let's then go ahead and try an example. So our first example says that a visual and performing arts group wants to hire a community events leader. The person will be paid $12 for the first hour, $19 for 2 hours, $26 for 3 hours, and so on. So I think it always helps to start by listing this out. So the first term is 12, the second term is 19, the third term is 26, and it would continue on this way. So we need to know some of our information. So we're going to write that T1 is 12. We know that. The common difference is, again, what we're increasing by each time. So if you look at the difference between 12 and 19, the common difference is 7. So what we should be able to do then is make the general term using that equation that we had before. So if we plug in the things we know T1 is 12, and we know D is 7, we can actually go through and simplify this so that it looks like a linear equation. So I'm going to multiply that 7 in to get 7n minus 7. When I combine the minus 7 and the 12, I get 7n plus 5. So Tn equals 7n plus 5. Again, notice that this is linear because all of these equations are going up constant by the same amount each time, which is exactly like a linear function. Then let's go on to part B. Part B says, what will the person get paid for 6 hours of work? That means that n equals 6. So we're trying to decide how much they'll make in the 6th hour, the 6th term. So all we have to do is plug that into our equation. So 6 is going to go in for n. So we have 7 times 6 is 42 plus 5 is $47. So this person on T6, again 6 because 6 is n, it's the 6th term, would be $47. Let's try another example. Here we have example 2. It's talking about the muskox and caribou of northern Canada. And it says in 1955, the population of the muskox was 9,250. Suppose that the growth was 1,650 each year. How many years would it take for the population to reach 100,000? So again, when we're doing this, it's best to always write out everything you know. So we know T1, we know it starts at 9,250. We know the common difference because it increases by 1,650 each year. And we're trying to figure out what term it'll be when the population equals 100,000. So that means we're looking for n to figure out the nth term when our answer is 100,000. So we should be able to create an equation for this and then work backwards to find n. So when we plug what we know into our equation, it'll look something like this. Then we just have to subtract that 9,250 to the other side, leaving us with 90,750. And then on the other side, that leaves me with n minus 1 times 1,650. So we can divide out that 1,650 to the other side, leaving us with 55. And then if we add that 1 over, that means 56 equals n. So that means that in 56 years, the population would be 100,000 if that pattern continued. Moving on to example 3, we've got this display of cereal boxes at a grocery store, and then it tells us some information. First of all, it says there's 16 boxes in the 3rd row from the bottom and 6 boxes in the 8th row from the bottom. How many boxes are in the bottom row? So we know a few things here. We know that it starts with 2 boxes. We also know that we add on 2 boxes every time. So again, if we write our information, T1 is 2, D is also 2. So we need to figure out a little more information. So let's write it out. So if we start our sequence at 2 and we add 2 each time, we know that 16 then is the 3rd row from the bottom. So that means the 2nd row from the bottom would be 18 and the bottom row would be 20. So the first question is, it says how many are in the bottom row? 20. So we see Tn is 20. Now we need to go backwards and figure out the general term. So let's use our formula. Now notice that when we're doing the formula, we actually are going to leave Tn as Tn. It's kind of like having an x and a y value. You need your 2 variables. Okay, so we're going to leave the Tn as a Tn for now as we're doing the general term. So from here, we're going to multiply that d into our brackets. So we get 2 plus 2n minus 2, and then the 2 and the minus 2 cancel, so really Tn equals 2n would be our general term. Now there should be a part C here that says, what is the number of rows in his display? So if we know that Tn is 20, and the equation is Tn equals 2n, we just have to divide that 2 to say that 10 is the number of rows in the display. Again, pause the video here if you need more time. And finally, let's move on to example 4, which says generate a sequence. So it says that this furnace technician charges $65 for showing up at a house, plus $42 an hour for his service. So generate the possible charges for the first 4 hours of time. So he shows up, and that costs $65 for the first, just for showing up. Okay, so that actually means that the first hour would be $107, because again, $65 just to show up, and then the $42, it would be the first hour. So if I add another 42, that takes us to $149 for 2 hours of work, $191 for 3 hours of work, and $233 for 4 hours of work. So this means that we have our value of T1, and we know that D is 42. So then part B says, what is the charge for 10 hours of time? First, let's come up with the general term. So again, I know that T1 is 107, and I know that D is 42. So if I multiply that 42 in, we get 42n minus 42, and when I combine the 107 and the 42n, we should get 65. So we have Tn equals 42n plus 65. Again, this is linear. So 10 hours of time means that we're looking for the 10th term, so n equals 10. So now all I have to do is plug in 10 into that n spot. So we get T10 is going to equal $485 if he has to work for 10 hours. All right, we're going to finish then today with some textbook questions. So please complete these problems, and if you're done, also try question 22. Again, these aren't necessarily tricky, but it just takes a little bit of practice, so please give these a try.